Under the National Electrical Code, the overcurrent protective device must be rated to protect the conductors from overcurrent damage. As the calculated load is now 790 amps, exceeding the ampacity of 500 mcm conductors, the conductors must be resized to a larger size capable of carrying 790 amps. Given that the building is intended for future provisions of 5 small mercantile tenants, it is prudent to consider the additional electrical load that may be introduced in the future. As such, there are two options to consider. Firstly, maintain the 800 amps breaker. This option provides ample capacity for future growth and eliminates the need for replacing the overcurrent protective device later. However, it may result in unnecessary oversizing of conductors for the current calculated load. Secondly, increase the breaker to 1000 amps. By increasing the breaker to 1000 amps, you ensure sufficient capacity for future growth while allowing the use of 750 mcm conductors, which would be suitable for the current calculated load. For a business shell with future provisions for 5 small mercantile tenants, it is recommended to increase the overcurrent protective device rating to 1000 amps and use 750 mcm conductors. This provides ample capacity for future growth while avoiding unnecessary oversizing of conductors for the current load. When calculating electrical loads, it's crucial to adhere to the National Electrical Code, or NEC, guidelines to ensure safety and compliance. These guidelines specify minimum requirements for various types of occupancies, including mercantile spaces. One common mistake in load calculations is using an incorrect volt ampere per square foot, or volt amps per square foot, value for lighting. For instance, using 2 volt amps per square foot instead of the required 3 volt amps per square foot can significantly underestimate the total load. This underestimation can lead to undersized conductors and overcurrent protection, posing a potential fire hazard. When the calculated load approaches the rating of the existing overcurrent protective device, it becomes essential to carefully evaluate the potential for future expansion. Mercantile spaces often undergo renovations or modifications as tenants change, leading to increased electrical demand. Failing to account for this potential growth can result in premature upgrades and costly disruptions. The selection of conductors is directly related to the calculated load and the ampacity rating specified in the NEC. Conductors must be sized to carry the anticipated load safely with consideration for ambient temperature and dirting factors. Paralleling conductors can be a viable option for large loads, but it requires careful attention to ensure equal current sharing and proper termination. Overcurrent protection devices, such as circuit breakers or fuses, are designed to protect conductors and equipment from overloads and short circuits. The rating of the overcurrent protective device must be coordinated with the ampacity of the conductors to prevent nuisance tripping or, more critically, conductor damage. When dealing with multiple tenants in a commercial building, it is crucial to provide sufficient capacity in the main service to accommodate their combined loads. This requires a thorough understanding of each tenant's electrical requirements and the potential for future expansion. Load diversity, which accounts for the fact that not all tenants will be operating at peak demand simultaneously, can be factored into the calculations. However, it is essential to apply diversity factors conservatively to avoid underestimating the overall load. The NEC provides specific guidelines for calculating the load contributed by different types of equipment, such as lighting, receptacles, and HVAC systems. These guidelines take into account the duty cycle and power factor of the equipment to arrive at a realistic estimate of the load. It's important to use the correct factors for each type of equipment to ensure an accurate calculation. In addition to the NEC, local codes and regulations may impose additional requirements for electrical installations. It is essential to be familiar with these local requirements and incorporate them into the design. The design of an electrical system for a commercial building should also consider energy efficiency. This can be achieved through the use of energy-efficient lighting, HVAC systems, and controls. Energy-efficient designs can reduce operating costs and minimize the environmental impact of the building. The selection of electrical equipment should be based on quality, reliability, and ease of maintenance. It is essential to choose equipment that is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or AL, to ensure that it meets safety standards. Regular maintenance and testing of electrical equipment are essential to ensure its continued safe and reliable operation. This includes periodic inspections, testing of overcurrent protective devices, and thermographic surveys to identify potential hotspots. When making changes to an existing electrical system, it is essential to verify that the existing infrastructure has sufficient capacity to accommodate the new load. This may require upgrading the service entrance panel boards or feeders. All electrical work should be performed by qualified and licensed electricians who are familiar with the NEC and local codes. It is essential to obtain the necessary permits and inspections to ensure that the work is done safely and in compliance with regulations. Proper documentation of the electrical system is essential for future maintenance and troubleshooting. This includes as-built drawings, panel schedules, and equipment specifications. The documentation should be kept in a safe and accessible location. The design of an electrical system for a commercial building is a complex task that requires a thorough understanding of electrical principles, codes, and regulations. It is essential to work with experienced electrical engineers and contractors to ensure that the system is safe, reliable, and efficient. In the scenario presented, where the calculated load increased from 748 amps to 790 amps after correcting a calculation error, the decision of whether to increase the overcurrent protective device rating depends on several factors. Firstly, the existing 800 amps breaker provides only a slight margin above the calculated load. This small margin may not be sufficient to accommodate future growth or unexpected increases in demand. Secondly, the NEC requires that conductors be protected at their ampacity. If the 500 MCM conductors initially selected have an ampacity less than 790 amps, they must be upgraded to a larger size regardless of whether the breaker is increased. Thirdly, increasing the breaker to 1000 amps would provide a significant margin for future growth. This could be particularly beneficial in a commercial building with multiple tenants, where electrical demand is likely to increase over time. Fourthly, the cost of upgrading the breaker and conductors should be considered. While increasing the breaker may seem like a more expensive option initially, it could save money in the long run by avoiding the need for future upgrades. Fifthly, the availability of suitable overcurrent protective devices should be verified. Breakers with higher ampacity ratings may not be readily available or may require special ordering. Sixthly, the coordination of overcurrent protective devices should be checked. Increasing the breaker rating could affect the coordination of the entire electrical system, potentially leading to nuisance tripping or inadequate protection. Seventhly, the impact on the building's electrical service should be assessed. The existing service may not have sufficient capacity to accommodate a 1000 amps breaker, requiring a service upgrade. Eighthly, the requirements of the local utility company should be considered. Some utilities may have restrictions on the size of breakers or the type of equipment that can be connected to their system. Ninthly, the opinions of other qualified professionals should be sought. Consulting with experienced electrical engineers and contractors can provide valuable insights and help ensure that the best decision is made. Tenthly, a risk assessment should be conducted to identify potential hazards associated with each option. This assessment should consider the likelihood and severity of potential outcomes, such as equipment failure, fire, or electric shock. In conclusion, the decision of whether to increase the overcurrent protective device rating in the scenario requires careful consideration of multiple factors. While maintaining the 800 amps breaker may seem like the simplest and least expensive option, increasing it to 1000 amps could provide greater flexibility and protection in the long run. It is essential to weigh the pros and cons of each option and make a decision that is in the best interest of the building owner and tenants. The NEC is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and industry best practices. Compliance with the NEC is essential to ensure the safety of people and property. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. The NEC is not a law, but it is widely adopted by state and local jurisdictions as the basis for their electrical codes. It is the responsibility of electrical contractors and engineers to be familiar with the NEC and to comply with its requirements. The NEC is a complex document that can be challenging to understand. However, there are many resources available to help electrical professionals stay up to date on the latest requirements. These resources include training courses, seminars, and online publications. The NEC is a living document that is constantly evolving to meet the changing needs of the electrical industry. It is essential for electrical professionals to stay informed about the latest changes and to incorporate them into their work. The NEC is a critical tool for ensuring the safety of electrical installations. By following its requirements, electrical professionals can help prevent fires, electric shocks, and other hazards. The NEC is a valuable resource for anyone involved in the design, installation, or maintenance of electrical systems. It provides a comprehensive set of standards that can help ensure the safety and reliability of electrical installations. The NEC is a cornerstone of the electrical industry and plays a vital role in protecting people and property from electrical hazards. When calculating the load for a commercial building, it's important to consider not just the current needs but also the potential future needs of the tenants. This is especially true for shell buildings that are designed to be occupied by multiple tenants, as their individual electrical demands may vary significantly. One approach is to estimate the maximum potential load for each tenant space based on the type of business they are likely to operate. This can be done by using the NEC guidelines for different types of occupancies. For example, a restaurant will typically have a higher electrical load than a retail store due to the use of cooking equipment and refrigeration. Another approach is to provide a generous amount of spare capacity in the electrical system to accommodate future growth. This can be done by oversizing the service entrance, panel boards, and feeders. While this may increase the initial cost of the electrical system, it can save money in the long run by avoiding the need for future upgrades. It's also important to consider the potential for changes in technology that may increase electrical demand. For example, the increasing use of electric vehicles could require the installation of charging stations, which can add a significant load to the electrical system. The design of the electrical system should be flexible enough to accommodate these changes without requiring major modifications. In addition to providing sufficient capacity, it's also important to ensure that the electrical system is designed to be safe and reliable. This includes using high-quality equipment, following NEC guidelines, and providing adequate grounding and overcurrent protection. A well-designed electrical system can provide a safe and reliable source of power for tenants, while also accommodating their future needs. This can help attract and retain tenants and increase the value of the building. Consider the impact of energy codes on the building's electrical design. Modern energy codes often require the use of energy-efficient lighting, HVAC systems, and controls. These requirements can affect the calculated load and the selection of electrical equipment. It's important to be familiar with the applicable energy codes and to incorporate them into the design. Also, consider the potential for renewable energy sources, such as solar panels. If the building is suitable for solar power, it may be beneficial to include provisions for connecting solar panels to the electrical system. This can reduce the building's reliance on grid power and lower energy costs. Think about the impact of the electrical system on the building's overall sustainability. A well-designed electrical system can reduce energy consumption, minimize waste, and improve the building's environmental performance. This can make the building more attractive to tenants and investors who are concerned about sustainability. Remember that the electrical system is an integral part of the building and should be designed in coordination with other building systems such as HVAC, plumbing, and fire protection. This can help ensure that the building operates efficiently and effectively.